stream is transferred. If you can hear us in the chat on YouTube, let us know. Okay, consensus layer call number 90, issue 555 on the PM repo. Looks like we will chat about anything merge related, any sort of client updates other people want to share. MEV discussion point, a couple of discussion points from Afri, and then open discussion. On the merge, I don't have any particular action items. Is there anything people want to go over today?
I have a couple of things related to the merge, but not like directly something like big or that kind of thing. So we can just go ahead right now, or
yes,
discussion.
Go for it.
Okay, cool. Okay, so first one is that was the issue with Taco and Aragon on the shadow fork number 7. It was a kind of a deadlock where Taco was sending fork choice updated to Aragon, and Aragon didn't respond in time, and then Taco timed out this request. And after that, Taco just stopped sending anything to Aragon. And Aragon was not responding because of it was like syncing and looking for a block. That's kind of like a bug in Aragon and a small issue in Taco. The issue related to these timeouts and whether to send again the request or not to send. I think that and that made a discussion with Perry, and I think we should add a kind of recommendation to the spec. Now it says now the spec currently says that consensus layer client may retry the call if it was timed out, but I think it should retry in some, especially in some particular situation when, for instance, CL client is syncing and it sends the fork choice updated or new payload, and EL went offline and for some reason didn't respond in time, and this request timed out. And CL should like retry this request once again because it is processing a block and it wants to get a response to proceed with the sync process. Otherwise, the sync can just get stuck. So I think that adding recommendation in the spec does make sense. I would also like to make a notice of this kind of thing to CL client developers, so they can think about it and take this into account of how the sync process on their side is designed and how does it work with respect to calls to execution layer. So they won't be stuck in this kind of situation.
Got it. Can you open up a suggestion in the execution APIs along with a detail of the scenario so that we can read a bit more on it?
Yeah, sure. I think I will just submit a PR. It's like a tiny change and it will describe this particular situation in it, and then we can.
Thanks. Any questions from Mikhail?
Prism currently doesn't do this, but it should not be very hard to add this. So yeah.
By just an update from Teco side. So since this has been seen in the Teco Aragon pair, we already merged a fix for ensuring that we are going to resend for choice updated no matter what. So even if we got stuck somewhere with the same for choice update data for whatever reason, at some point after a while we try to send it back to the execution layer, even if it timed out or whatever response we had in the past. So we try to ensure that we continue sending something in any case.
Yeah, I think what's also important is not only sending this, but also if a sync process, if a CL sync process depends on the response, so that the response eventually should inform the sync process. So it's kind of feedback.
So yeah, definitely. When we receive a response, we feeding back the result to the rest of the Deco modules, but we still want to have a more clear situation of what happened yesterday with regards of the sync process. I probably tomorrow we will discuss it with Dimitri as well, and have more analysis on where of the real root cause of the stuck of the syncing process yesterday, and we will connect to PR. I did it today. If we need to do something to ensure that the sync process doesn't stuck anymore.
Thanks. Anything else on this one? Mikhail, you had another one?
Yeah, another thing is we have been a bit analyzing and evaluating the latest valid hash thing and its importance for the network and for clients to implement it. And one thing that I'm wondering is it's not like explicitly specified in the optimistic sync specification, but I guess that clients like kind of agree on the exact behavior around not validated blocks and what happens. Yeah, just a reminder, not validated block according to the optimistic sync spec is a block that responded with the syncing or accepted from EL side. And yeah, what I'm wondering is the client's behavior, CL client's behavior after restart. Will they replay these not validated blocks, and will they try to resend the new payload and the fork choice of data to EL client for these particular blocks after the restart? I was just making this question, posting it in the chat and in the intro of Discord channel, but yeah, just requesting some attention to it.
Yeah, I'm not sure. I would assume they continue to insert blocks on the tip that they had not had. Inserting on the tip will either return accepted syncing or eventually valid or invalid, rather than replaying whole stretches of uncertain blocks. But I'm not sure how that's engineered exactly. Yeah,
I was like thinking about two possible cases here. One is not replaying them at all, and the other one is to replay them starting from like the most recent justified checkpoint. So because justified, we can assume that justified, if the block is justified, then the payload has been validated by 2/3 of the network. So it's pretty safe to deem this payload as valid. But what happens next is like, yeah, up to client implementation, definitely.
Does it matter, the distinction? Is there a case that you're concerned about?
Yeah, the case that I'm concerned about is that if it's not replayed, we can, like in a very particular scenarios, in a very particular edge case, it could result in like probably in data availability issues, where EL clients, if there were a payload that is invalid, the EL client can just drop it. Yeah, if CL is tries to sync with the chain that contains an invalid payload and doesn't send this payload after restart, then EL will never resolve from this situation.
Assuming EL can't find those invalid blocks on the network. Is that the assumption?
Yes, exactly. Yes, exactly. And I think that this is pretty reasonable assumption, because yeah, even if EL stores bad blocks, they will not expose them to the rest of the network. That's the reason to ask, and yeah,
Right. I
this is why
guess
it matters.
if this node that's in some syncing state is either going to think that invalid chain's the head for some reason, or get pulled onto a valid chain. And if they think that the invalid chain is the head for some reason, that means a lot of validators do. And so I think that it actually, in that case, you probably don't have the data availability problem. But it would, I guess, depend on the particulars of why these invalid blocks exist to begin with.
Yeah.
I guess if your fork choice is anchoring you on an invalid chain, then there's a lot of nodes that are really happy about the invalid chain for some reason and likely serving it.
Yeah, exactly. So that's a kind of like probably the situation that we don't, that we shouldn't care about that much. But anyway.
Does any engineer have some insight on what's actually happening here on node restarts while node is in optimistic mode?
For Lighthouse, we won't try and resend those optimistic payloads or the not validated payloads. We might send an FCU, a fork choice updated for it when we boot, but we're not going to try and replay any not validated blocks when we first start up again. We'll just kind of keep them and node them, and we might send descendants for them if we see them by the P2P network or the API.
Right. I'm not certain this edge case would, in most scenarios, result in a data availability problem, but if you want to think a bit more about it and write it down, I'd love to take a look.
Okay, cool.
Other merge-related items? Perry, we have a shadow fork coming up. Anything anyone needs to know or do on that?
Currently, the nodes are just syncing. The beacon chain hasn't had genesis yet, but we aim to hit TTD around Tuesday.
Great. And any update on Sepolia?
We have a TTD chosen. There was some hash rate fluctuations yesterday, but as far as I know, they've stabilized again, and most, if not all, the validators have already updated. So we should be prepared for a merge, even if it happens earlier.
Great. Okay. Any other merge-related discussions?
Gray Glacier went fine, by the way.
Yeah, I saw one message in all core devs about it, which was a signal that it went fine.
Yeah, we have
Congratulations.
one block on the bad chain, so less than 0.2% of hash rate.
Oh, that's great.
Not up.
And major infrastructure providers presumably are fine. Our exchanges and Furas and wallets and things.
I don't know.
Yeah, we might have heard
But
otherwise.
I haven't seen anything yet. So
Great. Okay, anything else related to the merge? Okay. Are there any other client updates people want to share? Okay, great. Moving on to MEV-Boost. Chris, can you give us the TLDR on the issue and what exactly you're requesting of this group?
Sure. Hey, everyone. The TLDR is regarding the builder specs. Currently, the get header request is not signed by the proposer, which means that everybody can request the current headers from the relay.
And getting a header, that's like a bid, right?
A bid, okay. Exactly. A signed builder bid. And having this open to everyone messes with the auction mechanics. So now it's turning out to be an open auction on the relay, which incentivizes builders to bid low, query the relays, and submit like incremental bids, outbidding each other by small amounts. If we would change this to a sealed bid auction, builders would be incentivized to bid on the high side, and no other builders would know about the bids of other builders. There was a lot of discussion on this GitHub issue that's linked. I can link it here again. And the conclusion basically is that a sealed bid auction is strictly superior. With the downside, it needs an additional signature by the validator. And
trusting the relay that they would not hand these out because it's not encrypted or anything.
Yes, I mean, this would just allow the relay to only serve the bid to the proposer. So it would, I suppose that relays would implement it. We for sure would implement it. It would be superior for the whole network. But there's no guarantees. But otherwise, the relays have no way of only providing the bid to the proposers. Theoretically, you could still bribe relays if they misbehave.
Another way would be if nodes were pre-registered as to what validators they have with the relay, such that the relay would only give it to those pre-registered nodes rather than a more dynamic request. The signature only says who this thing is for, and then I have to know who the counterparty is, correct?
I mean, yes, currently in the builder specs, there is just no signature on this request. So basically, we need to implement it this way. And this would not give the relay the opportunity to figure out if the request was coming from a proposer or from anyone else. Right, so even like a whitelist would not help in this case. The relay couldn't distinguish necessarily because the relay is open to any proposer. There is no whitelisting on the relays for the proposers. So it needs to provide the header to anyone who asks. I see, Mikhail, you have your hand raised.
Yeah, I just wondering what about the argument that the Ghost step just posted to the chat, and there was in the comment to the issue about like if there will be like a kind of sealed auction, there will be a way for validators and relayers to be bribed to provide this information. So what do you think about it? And does it make sense to I don't know, to not making it sealed and with respect to this kind of vector?
Maybe Steph, you have an answer?
Yeah, so maybe I have a few thoughts to contribute here. I think one of them is we should consider like the design space that opens up if we have sort of an arbitrary message signing method on consensus clients. I don't know if that's been like considered before, but something like a prefixed message signing for just authentication, and maybe like we can experiment with this sort of separately. I do think that for this question of leaking bids, it's tricky. Two things that come to mind to mention is just the way that things work today with miners. So miners do have asymmetric information. They see all of the payloads that they receive from the Flashbot system and the bids, and they are trusted not to sort of use that. And if we sort of make the bids private and in a MEV-Boost environment, then we would be sort of replicating that, right? We'd be trusting the validators not to publish the bids for their independent slots. Maybe that's better, but perhaps not fully robust, since it can still be sort of bribed to be used, or they can use it themselves. So there's still some advantage to like a large validator pool who's able to see bids from many different entities and then perhaps is able to beat it themselves. The final point to consider is like, how does this fit with like future PBS design? Does a future PBS design explicitly require bids to be public? And if so, like maybe, that's just the way that we should go. But I think that's still very much so an open research question. TLDR, is there a way to like decouple making changes to the consensus client by just having a generic signing method that allows to build this without necessarily committing to open payments or closed payments?
On the large validator pool example, they such an entity who is potentially also searching and is a validator can always beat the bids, right? Like they always have the opportunity to use their own block. So I don't know, does this change it?
Does it change it? No, it doesn't change like the ability of a single individual validator from like being to put whatever they want in their block.
Right.
In terms of an arbitrary message signing scheme, I think the challenge here is not how do we sign the data, it's more about how do we add that into the flow of producing a block. So I'm not sure that having an arbitrary signing scheme would help, because you need to make sure that the MEV-Boost can trigger the request to get it signed and all that kind of stuff, and that's probably the tricky thing.
Yeah, my naive thoughts was like there is like several fields in this request, right? If I'm recalling correctly, parent hash, slot, and pop key, the proposer's pop key. So there could be a signature or a structure contained in these fields, and then this signature may be this message and the signature may be submitted to MEV-Boost, and then MEV-Boost may use this kind of like signature and data structure, signed data structure to pull data from a relay. So CL should just probably sign it once in the beginning of slot, when it knows what the head is because of the parent hash. And yeah, that could work this way. Not sure if it's complicated or not.
I guess one minor concern is validator privacy, right? If you just have one relay and every validator is talking to that relay, so that relay could literally map all the slots with the IP address.
That's likely the case already, right?
That's already the case because you need to get the payload and submit the signed block. So this is a call that is already mapped to the validator.
Right. Micah.
So I think I'm missing something here. Who is signing something? So a builder builds a block, sends it over to the relay. Who's signing that? The builder doesn't need to sign it. The builder's already signed it, right?
Well, they're signing a header.
It's to the relay.
Yeah, the header, which is a bid.
Exactly, and here in question it would be a signature by the validator to allow the relay to know that this request actually comes from the validator only. and would
Oh, I see. So
send the
you're
bid.
trying to make it so only the validators can get the next bid, or only the next validator can get the next bid. Not anyone can ask for it.
Right.
Yes, exactly.
Yeah. So to answer Danny's question earlier, a large pool can put whatever they want in their own blocks. This allows that same large pool to potentially. I guess not. Okay. So yeah. So my general feelings are that I'm not a fan of obscuring the problem. Like the fundamental problem here is that there is some number of entities out there who know what the set of bids are, and those people have an advantage because they can, they can outbid. I don't like the idea of saying that we solve the problem by just narrowing the set of entities who are allowed to have that information. It just means that it's now an unfair game. So you turn a fair game of a bidding war into an unfair game where the only person who can participate in the bidding war is the relay. And that feels like not the right solution to the problem. Like I understand, like we want to not have a bidding war, but like we're not actually solving that. We're just making it so only certain people can play. And if you have like 10 relays, let's say, those 10 relays get to play and no one else gets to play. And so now the game is become a relay, so you can get the flow. And once you have the flow, now you can participate in the bidding war with everybody else. And if you don't have a relay, you can't participate, and so you're playing underhanded. And so I appreciate the problem and the need for potential need for a solution. I don't think that giving relays privileged information is the right one.
Yeah, and some sort of reputation on relays.
Clarify what privileged information you mean? You mean like the actual blocks?
Seeing the bids.
They see the bids. So if you're,
but that's literally why we have
builder,
relays, so that they do that.
Also, if you're a builder and you want to you want to submit the smallest bid possible and win, right? That's your goal, because you get to keep the difference. And so if you can't see the bids, but someone else can see the bids, that means they're going to win more than you, because they will be able to submit bids that are lower, and so they're going to make more money. And so the relays, if we say only the relays can see the bids, no one else can see the bids, then as a builder, the optimal strategy is to go become a relay, because the relays win. Like in the long game, the relays are the only ones who win. And so builders all have to be relays.
The relays have a trusted role in the setup, right? We know that. I mean, that's just because right now we don't have proper PBS.
Correct,
in
but
PBS, this will not be the case.
This disincentivizes people trusting new relays, because all of a sudden being a relay gives you an advantage. So it's less likely that you're more willing to work with new relays.
Right, but that doesn't seem like a relay is a trusted role, right? We know that.
It's also a matter
basically the builders trust with their flow, and the validators trust that the relays publish the blocks and not withhold them.
Do the relays in the current plan, do the relays see the whole block or only the bids right now?
They see the whole block once a block is selected.
They have to, because they guarantee that the block becomes available.
But they don't.
Otherwise,
they don't see it until selection.
No, because the relay also guarantees that the right fee is paid to the validator.
Right.
The relay needs to simulate the builder bid and give certain guarantees to the proposer. Else builders could just claim whatever they want.
So it's not until full PBS that we actually turn relays into untrusted.
Correct.
We don't need a relays anymore in full PBS. They will just be builders and proposer.
Right. Relays serve as essentially what the protocol can give you.
Yeah. Relays are the current trusted intermediary that solve the absence of PBS.
So if I understand your argument here, Dankred, you're basically saying that relays are already trusted very significantly, and this doesn't change that in a significant way.
It does give.
I mean, we know that. We don't I mean, this is not news to me. I mean, this is clear that we built this trusted role into them. And the idea is that you can have that hopefully trustworthy individuals, organizations take on that role, so that people actually believe if I don't know Flashbots does this, or Etherscan provides this, or someone, then they will actually like be trustworthy enough. And if they aren't, then like if someone can raise suspicion that they aren't, then they will be kicked out. And
Right.
somebody will-
I guess the question here for me is, does the discussion of open versus closed bids drastically change the trust assumption that we're willing to put on the relay? You know, if not, then you know I think it does buy you something. If it does, then it doesn't.
Like, I mean, like honestly, the problem is like isn't just the bids. I mean, they see the full block. They could just like, if you don't trust them to do that, they can just take even all the MEV that you extracted in your block as a builder, reassemble it, and make it their own block. So it's like
Right, and thus the trust assumption here isn't
something new.
changed.
I think we need to finish this conversation quickly because Dankred is going to be too far away to hear.
Slowly disappear.
Yeah,
sorry.
just falling away into the distance.
Wait, is my microphone not set up correctly, maybe?
Yeah, you thought you were using your headphones, but you're really walking away from your computer, Mike.
Yes, it seems so.
We can still hear you though, barely. I do want to point out in terms of, I just want to point out potential design here and how to get the signature. I don't think it's necessarily a good idea, but it is a design that we have not discussed before. Essentially, when there's a register kind of validator message, which registers, I think, the fee recipient, but other things can be put in there. So you could actually register another key. That's your kind of like MEV-Boost application key, and that key could sign non-consensus messages for authentication purposes, rather than having to go into the validator client and go into, you know, a much more kind of privileged signing space on that validator key. Just tossing it out there.
Yeah, that's actually a possible approach that could be reused for other purposes and remove additional signing. So I think I just want to point out one thing regarding the trust assumptions to the relay. It just changes the power and the transparency a little bit. So if it's a sealed bid auction, it gives the relay and the validator additional, especially misbehaving ones, additional negotiating power, because they can then ask for bribes to reveal the current bids to close parties. And yeah, on the other side, it's probably leading to lower bids by the builders. So the validators would conceivably receive less rewards, less MEV rewards.
So if I understand correctly, the concern with the escalating bids is just it's spammy, right? Like if you have 1,000 builders all building, or even 2, and they're racing each other. Can we address that similarly to how we address gas price escalation, where like they're replaced by fee, where the next bid needs to be substantially higher than the previous one by a percentage, and so it's exponential pretty quick, and you basically have a finite number of bids that can actually show up for any given block. And that would also encourage people to get in first, because if the next bid has to beat yours by, let's say, 10%, then you're no longer incentivized to be as strongly to be last, right? You want to be the first guy that bids, 9% less than what anyone else can afford to pay.
Yes, that's also an option for well-behaving relays to implement. Of course, there is nothing that can force this behavior on misbehaving relays. Another thought.
Right, so a misbehaving relay could offer more MEV? No, less MEV.
A misbehaving relay, I think, can this is more noticeable. So like if you submit a bid that you know should have beaten the previous bid and it never shows up, and this happens a couple of times, you notice it. Whereas if someone is, if a relay is stealing bid flow and they're outbidding people by just like a tiny little bit, that's easier to mask. Like the relay can just, you know, vary how much they outbid by, and they win coincidentally, you know, 70% of the time. And so I feel like being more noticeable is valuable because proposers will stop giving to that relay if they detect it. Whereas if you can't detect it, then you don't know that you need to stop giving to the relay. You just are like, I'm losing a lot. I don't know why.
But I mean, as a validator, what's the downside of, like, I mean, basically I determine what I accept from the relay. I could say, oh, I'm fine with 10% increase, or I could say I want it more granular, 1%, because then I get better bids, right? Because otherwise you might be leaving 9% on the table. So like, doesn't this create just a race to the bottom where validators will just decrease that constant?
I think it creates a race to the bottom, but in a way that is acceptable to all the parties involved, including the spam. So basically, relays will, you know, allow the race down to the point where the spam is too much for them to handle. Then they'll just say, hey, we're not going to relay anything like that.
I guess the concern is that, like, if you have a bigger pipe, then you can handle more bids. So like that. Yeah, so that's a downside for at-home validators, that they say like they can't handle 0.1% increases, whereas like professional operators can easily handle that and they don't care.
Yeah, that's fair, I guess. The relay isn't doing any sort of filtering before, like a relay that is helpful to validators could do some of that filtering.
Yeah,
and,
it's
like,
true. I mean, why
block it
does the relay even need to send several bits? That's a good question, right? Why can't the relay simply send one bit exactly at the cutoff point and say, here, this is it, and do all the filtering?
Or at least, you know, one bit every second, maybe.
I mean, why does it need it? Why do you need another bit? Like, this is
I would assume I would assume there's value in getting one early, just so you have a block prepared and you're ready.
Right.
Like, you don't want to wait until the last absolute second.
Sure, but like, there's no, I see little value in a continuous. You could say you can configure 2 time points with your relay. You say like, I want 2 seconds before and 100 milliseconds before, but there doesn't seem to be much value in a continuous flow.
Is that how it's designed? A continuous flow and then MEV-Boost filters rather than the relay pre-filtering?
No, it's would be the relay filtering a continuous flow of incoming blocks, I think.
And then only giving the highest bid to MEV-Boost.
Yes, at the point when the bid asks, yeah.
Yeah, okay. So this isn't an issue. The continuous stream bombarding a hobbyist validator is not an issue.
It doesn't mean you can't have a hobbyist relay.
Absolutely. I mean, you also need to simulate the bits, and like that's a lot of infrastructure to run and have the data availability, else you get published or punished. So running a relay will be hard.
Yeah, and I think that having the design in place to allow relays to compete on that, like how much they're allowed, the bit increment, I think is good because it encourages relays to be beefier and stronger and better and faster, et cetera, because it allows them to reduce that a bit increment, which gets more validators presumably listening to them, right?
Yes.
But put in place the infrastructure to allow competition on that front.
I mean, I think the relay utilization and performance is not the main point necessarily. It's more like the auction structure and how and the value of the bits, because we expect to just have enough caching on the relays to be able to handle bombardment by entities asking for bits. I wonder if it's a consideration to be closely aligned with future PBS designs where bits would necessarily be somewhat public. Like,
Yeah, I
is that the case?
definitely would rather
Right.
not do a certain auction now and then change that once we have PVS if we don't have to, like in terms of design. Why is that?
Bypasses and make privileged connections with large validators to send them directly.
Correct.
Right.
Yeah, so that you don't leak your bid.
They essentially act as a relay to privileged parties.
Yeah, I think it's somewhat inevitable that even if we have like some public relays, that there will be private connections directly to large validators. I think the question is, should this be the norm or the exception?
So it does look like there's a lively discussion going on this issue, and I think there's now a number of people that are more informed, and we've kind of explored the design a bit more. Can we take this to the issue? I don't think we're necessarily going to come to a conclusion on this call.
I personally am happy with the outcome. It was a really interesting discussion, and it's good to have everyone thinking a little bit about the implications. And I think it's all right to continue the conversation on the other channels now.
Is there a Discord room where this discussion is happening?
I think the most closely would be on the ETH R&D, the block construction channel.
Okay.
And the issue is this one here, which already has a bunch of comments.
Cool. Thank you.
Thanks, everyone.
Yeah, I appreciate that. Since we're on the topic, is there any other MEV-Boost updates or discussion points for this group?
Just let me add, please test on Sepolia. Our build and relay is available.
Great.
Yeah, I have a question around this because is the activation topic. So when we should start working, requesting the builder. So there is this discussion around waiting 10 or 16 epochs after the first execution finalization, and show what we should do with this regard for Sepolia. So I'm thinking that on the CL side, we should just rely on the 200.04 response. The relayer will give us if we are asking before this delay, and actually do nothing. What do you think?
I think we can configure our relay on Sepolia to not produce blocks for like 16 epochs. That should be fine, and we will return 205.
Yeah, perfect.
Okay. Other MEV-Boost discussion points? Great. Afri left a comment. I do not believe Afri is here, but I'll quickly go through it. Couple of conveniences, as Afri said, that we should be reviewing as we move towards the merge. Pulling chain configurations from GitHub. The repositories were planned to serve as a reference, and there's security implications of pulling specs from third-party services, which are hard to gauge. In fact, we had kind of a weird GitHub issue on a repository name change that did lead to some potential issues that were not exploited and are now patched. But so that is a recommendation from Afri. We can discuss that recommendation if anybody feels otherwise.
Well, so what I would be, is the proposal to remove them simply from GitHub, or is the proposal to not, I mean, I've
he's
seen some
suggesting not to
posting.
dynamically pull them in builds, and instead they're used as a reference. They're used as something you can integrate into your client, but not to, every time you build your client, have to have that dependency, I think is the suggestion.
So this, at least my working assumption as one of the people who's been, has updated these from time to time, is that nobody just blindly pulls it, that they have some kind of check, whether it's sort of pinning some commit, whether it's, you know, with get some modules with some other method. Nobody's, at least should be, blindly trusting repo to begin with. So I'm not sure I understand the concern.
Then I'm not sure I understand how you're using the dynamic pull.
Well, when you say dynamic, because when I've seen Ofri's GitHub issues, I don't know if there's any PRs on this yet. They are not limited in scope to simply dynamic pulls, as I understand that phrase. They affect the repo and any use of the repo. So when you say dynamic pull, this is not necessarily run curl or wget at build time per se and just accept whatever random garbage GitHub responds with.
Okay.
This is, there's a specific commit in say the merge testnets or some ETH clients
that you would point to, right?
Yes, and to me that is, and it's certainly possible to pin that down further, the usual methods, SHA, hashes, whatever. But the point is, I don't see how, and there's certainly a risk of centralization generically that GitHub presents with any development approach. But that's,
yeah, I suppose if GitHub's honoring a hash of a commit, then there's not much an attacker can do.
Right. What I would suggest is an open new attack surface. If there are other reasons to do this, and I know some of his Ofri's issues have mentioned or alluded to this, for example, like just organizational issues. So maybe, you know, Sepolia or Trotter, while there's a proposal to say, well, maybe rather than have these sort of EL side on one repo and the CL config on the on another repo, to put them in the same repo. I mean, and that kind of thing is a little different to me. But in terms of just pulling them from GitHub altogether or discouraging even this kind of pinned pull as part of a build, I don't see the value in that.
Yeah, I mean, I understand the argument. Something that we did see was a rename of a repo, and then someone, and GitHub honors redirects to the previous name, or sorry, organization, the previous organization, unless somebody registers the new organization, which is, you know, clearly seems like a major issue with GitHub. But I think his abstract security implications of pulling specs from third-party services are hard to gauge. It probably, you know, when you start thinking about some of these weirder edge cases and the dependency on GitHub, that's probably the concern. I'm not making a claim one way or the other on the suggestions of Apri, but I just wanted to highlight them because he did put them into the issue.
Sure, and I would acknowledge that this is sort of an odd behavior, perhaps, on the part of GitHub, exploitable for sure.
Yeah, especially if you're pointing to master, right, rather than maybe a pinned commit.
Yes. Well, but that's the other part, is that if you're pointing to some specific commit, then it seems a little irrelevant, because it's, the worst case is maybe they remove it, but then the build should fail. There's no either the commit exists or it doesn't. I mean, more broadly, I think there is an issue here, but it's kind of a weirdly specific fallout manifestation of what would be potentially borderline catastrophic. I mean, if to pin this on the just simply network configs. I mean, there's so much else that people depend on GitHub for in terms of code and
The dependencies are
it
deep.
seems like an odd target to me, but that's
Okay. I would say when doing so, being careful is important. Just given some of the weirdness that we've seen. Also, but I'm not laying down the hammer on this one.
Yeah, I think the primary takeaway is don't use master, use a specific commit hash. I think as long as everybody's doing that, we're mostly protected.
Right, barring some deeper GitHub bug or GitHub takeover problem.
Even that shit. So if you're using Git, it will validate the hashes for you, so you can't actually be screwed by GitHub.
Indeed.
Unless you're using just like raw.github user content, whatever. So I guess two things: don't use master and use Git. Don't use curl.
Okay. And the other thing was checkpoint sync from Infura. He suggests that we should be moving towards P2P state sync instead of checkpoint sync, and providing alternatives, or coming up with a feasible P2P protocol, and ensuring that users can provide their own checkpoints. I responded to this. It is requisite, I think we all know, to get out of band information to perform sync. Either a checkpoint route or full checkpoint state. But if you've already had to find the route from somewhere you trust, maybe you might as well get the state and not add the P2P complexity. I think that's what we're kind of all operating on. But we are also probably relying pretty heavily on Infura as a single source of information rather than some sort of multi-party, multi-authority source of information. And I think we can and probably should do better. But I also believe that this group is still moderately biased towards not adding state retrieval inside of the P2P. I guess that's more of a response to Afri than to y'all, but any questions or any discussion points on this?
I just wanted to briefly go back to the previous one about GitHub.
Yep.
One thing that we haven't specified is the format of those repositories, really. We haven't documented what should be in there. We have a couple of things in there. We have like a Genesis state, the boot nodes. We have a deposit contract Merkle tree hash thing that helps avoid some deposit downloads. Like there's a bunch of stuff. And now we're adding S1 to the mix as well. And I think there are incompatibilities between clients there as well, or at least there used to be. So maybe it's worth an effort to actually document what's in that repo, and then it sort of even more decreases the risk of having it in any one particular location, because at least we're like agreed on what should be in there. And then that also helps people launch their own test nets and stuff. With all clients supporting the same thing.
Yeah, I don't disagree. Is there confusion or disparity in how we specify the information here, or is it just not? We usually do it in the same way, but it's just not a standard?
I think there's 2 formats for boot nodes and 2 formats for ETH1 Genesis, if I remember it right.
I see.
Like vaguely from interop events.
I think there's even more ETH1 Genesis formats.
Okay, there you go.
Like
I mean,
so the big ones are BISO, Nethermat and Geth, but BISO is also a bit different than Geth.
Yeah, so like if we move this into one repo, it's like an obvious good thing to do in the same go.
The problem is that we have like the different clients have different use cases and different things. So for Geth, it's like we only need to support the hard forks basically in our Genesis, because we're only following main chain, mainnet. But for other clients, they want to have a more granular approach to the Genesis block. Basically, they want to enable or disable EIPs one by one, and that's why they have a different Genesis format. And they need it for their use cases that they have next to Ethereum mainnet.
I would presume the more configurable format has all the information to be converted into the Geth format, just from my understanding.
Kind of, probably, but we don't have this EIP to hard fork mapping anywhere in the code.
Okay, so there are potentially some issues in trying to unify. Nonetheless, if somebody wants to take the charge, by all means.
Cool. To the point about states, I think there's two things to point out. Like, checkpoint sync in itself isn't inherently more or less secure than syncing from Genesis, right? Unless you trust your source. But I think in general, we're moving towards this world where you need to have one point of reference, like, tofu in SSH, and then where we get states from is a bit of an open problem. What's nice about this particular problem is that once you have a hash, it's very easy to verify the data you're getting. And I mean, it's just dumb data at that point. So I think one reason why we haven't really worked very hard to solve this is because we envision a fairly easy solution once, like, should this ever become a real problem.
Yeah, I agree. Nonetheless, if we don't create some sort of standard and encourage a bit more adoption, we will continue to rely on a single provider. Which, you could definitely argue the damage that such a provider can do is actually very limited. But still, there's damage that can be done.
Well, I could use my usual Aerophile plug here.
What is the state of the Aerophile?
We actually have community members running servers that provide Aerophiles. We can also use them in Nimbus instead of a database. So the way that we're using them right now is that when we have multiple, multiple beacon nodes, they can share, the block storage for providing blocks via P2P using Aerophiles. So we have something like, I think, 12 beacon nodes running on a server, and it uses the space of one. So I would say the format is fairly good, fairly stable. I'd encourage others to take a look at it. It's there, it's possible to use. I'm like always like 1 week away from writing an EIP actually, and then something else pops up.
All right. Anything else on Afree's checkpoint sync comments, and if he joins us in a call or two, we can discuss more with him. Okay. Next item on the agenda, open discussion, spec, research, anything else? Okay. Thank you. Happy Sepolia, happy Shadow Fork, happy Great Glacier. Talk to you soon. Good night, Paul.
Bye-bye.
All right,
Bye.
everyone. Thanks, everyone.
Bye.